Okay, so in this lesson, we're going to continue talking about multiplying and dividing expressions with common bases. Make sure before you continue that you review the previous part of that lesson where we talked about reviewing exponential notation, and we also talked about evaluating expressions with exponents. So make sure you review that before you continue on with this. Okay, so in this lesson, what we're basically going to look at are some properties. Some properties on what do I do when I multiply like bases that have this, what do I do when I multiply expressions that have the same base? What do I do when I have expressions in which I'm dividing like bases? And so that's what this is going to be about. It's a very simple process. To get started, though, let's kind of review this idea. So number one, we know this. We know that x to the third means x times x times x, right? So x to the third, that's what this means. So I'm taking the base x and I'm multiplying by itself a factor of 3 times. Okay, so you see 3 factors of x. And number two, what if I had this? What if I had x to the fourth times x to the third instead? What if I had that? Well, let's think about what that means. So if I cover up, let's say I cover up this part here, okay? What that x to the fourth means is that same idea. I'm taking the base x and I'm multiplying it by itself 4 times, right? So I have this. I have x times x times x times x. So that part, 4 factors of x, is here. But I'm also multiplying it. I'm also multiplying it by 3 factors of x. So x times x times x. And if you look at this, all these factors here are the same. They're all x's. But how many factors of x do you see altogether? There's 1, 2, 3, 4, 5, 6, 7, right? So I can write this product here as an exponent. Exponential notation. I can write this as x to the 7th power, right? Well, let's think about this. So rather than listing all of this way, all I need to do is compare this exponent that I ended up with what I see here. So I have x to the fourth times x to the third. If I take those two exponents and I add them, 4 plus 3, I get this, don't I? And that's the idea. So if you look at this one, if I have x to the fifth times x to the, let's say, third, that same idea. Rather than saying x times itself 5 times, like this, and then times, and then x times itself 3 times, I know now that the product here is just x to the, and then just to remind you, 1, 2, 3, 4, 5, 6, 7, 8, right? But all you need to know was that all I had to do was take those exponents and add them up. 5 plus 3 is 8. And that brings us to one of our properties. So one of our rules or properties, and that's this. Whenever I have and I'm going to use this different notation, but whenever I have b to the m power times b to the n power, as long as the bases are the same, then all I need to do is add those exponents. So when I multiply b to the m times b to the n, my base is still b, but my exponent is now going to be the sum of those exponents. So b to the m times b to the n is b to the m plus n. Okay? And that's going to be the product rule for exponents. Product rule for exponents. Okay? Product rule for exponents. If I look at division, so you see here I multiplied, right? So let's look at this. So number 4, what if I had x to the 6 divided by x squared? X to the 6 divided by x squared. Well, if I do the long way, The numerator means 6 factors of x. So x times x 6 times. And that's what you see here. The denominator means 2 factors of x. So x times x. And if I reduce these variables, these factors of x divide out, and these factors of x divide out, right? And so in the numerator, when you multiply that out, 1 times 1 is 1. 1 times x is x. X times x is x squared. X squared times x is x cubed. And then x cubed times x is x to the fourth. Because remember I have 4 factors of x, so x to the fourth. Divided by 1 times 1 is 1. And any expression divided by 1 is that expression. So that becomes x to the fourth. Okay, now I want you to think. When I multiplied like bases, see that, like bases, what did it do to those exponents? I added them. So x to the fifth times x to the third is x to the eighth. I want you to think about this though. When I divide like bases, see, you're dividing like bases, right? You're dividing like bases. When I divide like bases, what do you think you can do with those exponents? I want a 4, I have a 6 and a 2. You're going to subtract. So dividing like bases, subtract exponents. Dividing like bases, subtract exponents. So when you look at this other rule or property, where we have b to the m divided by b to the n, I'm dividing like bases. You're going to do what to those exponents? You're going to subtract. Now, remember subtraction, the order in which you subtract does matter. So when you write this, you need to say the base is b. You're going to, for the exponent, you're going to put the exponent that's in the numerator first. So m minus, and then the exponent in the denominator. That's how you have to do that. M minus n. Okay? So that's your 2 properties. Those are 2 very important properties that you're going to use. And by the way, this is called the product rule for exponents. This is called the quotient rule for exponent. Quotient means division. Quotient rule for exponents. Okay? All right, so that's that one. Now let's look at some examples. So I'm going to write the word example here. Let's just call this example 1. Okay, example 1. All right, and then the directions will say something like this. The directions will say simplify each of the following, or simplify. It may say something like simplify, or it could say simplify expressions with the exponents. Simplify expressions. Let's just write it like that. Okay, so it's the first example. So number one. Let's suppose we had m to the 8th times m to the 2nd. What is that? When I simplify that, what do I get? First of all, remember what rule am I using? We only know 2 so far. We only know the product rule for exponents and the quotient rule for exponents. Product rule, quotient rule. Here I'm multiplying, right? The bases are the same. So I'm going to use a product rule. So the product rule says that m to the 8th times m to the 2nd will be the base, which is m, raised, and the exponent will be 8 plus 2. You're going to add those exponents. Well, 8 plus 2 is 10. So there's your answer, m to the 10th power. Very simple, not difficult at all. Number 2, if I have 3 to the 5th power times 3 to the 3rd power, notice the base is the same, so you're multiplying, right? So it becomes 3, which is the base, raised to the 5 plus 3. So that's 3 to the 8th power. Okay? That's all you do. That is it. Very simple, isn't it? Very simple process. Number 3, what if you had t to the 12th power divided by t to the 4th power? So t to the 12th power divided by t to the 4th power. Well, notice this time you're dividing like bases. You're dividing like bases. So what do you do those exponents? You subtract. So you're going to say the base is t. Always remember the base, this base is the same base here, raised to the, and now since I'm subtracting, you got to put the exponent of the numerator first. You're going to say 12 subtract 4. 12 subtract 4, so the answer is t to the 8th power. Okay? All right, let's look at this example. Okay, what if I had this? So look at number 4. We have x to the 8th times x to the 5th divided by x to the 3rd power. X to the 8th times x to the 5th divided by x to the 3rd. Don't make that difficult. Always look at what you have in the numerator first. So notice in the numerator, I have this product. So in this problem, I have to actually use both properties, the product rule and then the quotient rule. See that? Product rule, quotient rule. So when I look at the numerator, the product rule says that when I multiply like bases, I add exponents. So that's going to equal, and then what's x to the 8th times x to the 5th? Will be x to what power? 8 plus 5. 8 plus 5 is going to be 13, right? Divided by, and then x to the 3rd. So that's where I'm at. Now I'm going to use the quotient rule. So notice to go from here to here, I use the product rule. And then to go from here to the answer, I'm going to use the quotient rule. So x to the 13th divided by x to the 3rd will be x to the, and remember you subtract exponents, so 13 minus 3 is 10. So here we use the quotient rule for exponents. So the answer is x to the 10th. So notice is very important. You understand how we went from here to the answer. So notice I had to use a product rule and then the quotient rule. Okay? All right, so let's look at number 5. What if you had 8 to the, let's say, 6 power divided by 8 squared times 8. Let's say we had that. Okay? 8 to the 6 divided by 8 squared times 8. So it's very similar to number 4, except the product rule that we're going to use is going to be in the denominator of this fraction. So let's simplify the denominator. So you got 8 to the 6 divided by 8 to the 2nd times 8. So the bases are the same, so I add those exponents. Remember, there's no exponents understood to be 1. So 2 plus this 1 is 3. So that becomes 8 to the 3rd power. So that was using the product rule. Product rule to go here. Product rule. Then now I'm going to use the quotient rule. So 8 to the 6th divided by 8 to the 3rd. So quotient rule, you're going to subtract exponents. That's 8 to the 6th minus 3rd, which is 8 to the 3rd, right? 8 to the 3rd. And so there's your answer. And if you want to, you can go ahead and multiply that out. 8 to the 3rd means 8 times 8 is 64, right? 8 to the 3rd means 8 times 8 times 8. So that's 64 times 8. And then 64 times 8 is 512. So you could say R 512. Okay? All right, so that's number 5. Okay, let's look at number 6 now. So number 6, let's suppose we had this in number 6. We had negative 2 x to the 4th y to the 5th times 3 x y squared. Okay? Don't make that difficult. It's not difficult at all. All right? Now, when you do more practice with this, it's very easy to get the answer right away. But in your mind, this is what you got to think about. So I have 2 sets of expressions in parentheses. So I have this times this in parentheses. 2 sets of parentheses. And let's put the coefficients together. So I can write this as negative 2 times a negative 3, right? And then I can put the x's together, x to the 4th times x, just like that, x to the 4th times this x. And then I can put the y's together, y to the 5th times y squared. Okay? And now I'm going to simplify each of those parentheses using our properties. Well, we all know that a negative 2 times a negative 3 is a positive 6. We all know that x to the 4 times x, using the product rule, I add exponents. 4 plus 1 is 5, so you get 6x to the 5th. And then y to the 5th times y to the 2nd is y to the 7th. And so there's your answer. But most students skip this step. Most students just look at this since this is all product. Remember when you read it, I read it as negative 2 times x to the 4th times y to the 5th times 3 times x times y squared. So negative 2 times 3, positive 6. X to the 4th times x to the 5th. Y to the 5th times y squared, y to the 7th. So most students go from here to here without actually writing this down. Okay, so that's number 6. Okay, let's look at number 7. Number 7. Okay, so number 7, let's suppose we had this. Now, be a little bit careful how you think about that. So remember, our two properties are the product rule and the quotient rule. Quotient rule for exponents. So notice when I multiply like bases, I add exponents. Those bases have to be the same, right? When I divide like bases, I subtract exponents. So if you just look at the numerator, there's nothing I can do in the numerator. There are no like bases in the numerator, and there are no like bases in the denominator. But if you look at the fraction as a whole, there are like bases. So you have w to the 8 divided by w to the 7, z to the 4th divided by z, and then 28 divided by 4. So for some of you, you may want to do this. You may want to write this into separate fractions. So in other words, 28 divided by 4 times w to the 8th divided by w to the 7th, notice dividing like bases, times z to the 4th divided by z. So this means this. Okay, now let's simplify. 28 divided by 4 is 7. W to the 8th divided by w to the 7th. We need to divide like bases. You subtract exponents. 8 subtract 7 is 1. So that's just w. Don't put the 1 there. You can, but we prefer that you don't because it's understood to be a 1. And then z to the 4th divided by z. Remember, there's no exponent. It's understood to be a 1, right? So 4 subtract 1 is 3. So that's z to the 3rd. And there's your answer. It is not difficult at all. It's a very simple process. All right, let's look at number 8. Suppose in number 8 I have negative 3v to the 4th power times 2v times 5v to the 5th power. Let's say I had that. Okay, so it's very similar to this one that we had here. Okay, and remember what I said. Most students, almost all students, will go from here to the answer. They understand this right here means the same thing as this, and then from in their mind when they think of this, they get this. All right, so you can do that here if you want to. But if you need to rewrite it in that intermediate step, go ahead and do that. So what this is that you're multiplying negative 3 times 2 times 5, right? So negative 3 times 2 times 5. Then you're going to multiply the like bases together, so you have v to the 4th times v to the 5th, right? And so if I multiply these coefficients here, these constants, a negative 3 times 2 is a negative 6, and a negative 6 times 5 is a negative 30. Now here, I'm multiplying like bases, so I have to add those exponents. 4 plus that implied 1 is 5, and then 5 plus 5 is 10. So I get v to the 10th power. So there's your answer. Now also make sure that your exponent looks like an exponent. It's very important that all these exponents truly look like exponents. All right. Don't make it look like this. Don't write as, and some of you will, and you're going to be upset, but don't write it as negative 30 v 10 like that. When you write this, that means this, negative 30 times v times 10. Okay, so don't write it like this. This 10 needs to be written as an exponent. So make sure you write as an exponent. Okay? All right, let's do number 9. Number 9, let's suppose you had this one for number 9. We had 1 6 times c to the 8th power times d, and then that's being multiplied by let's say 36 c squared d to the 4th. Okay? All right. So So you can write it like this, just like we did. So you could say, all right, I'm going to multiply. So all these are products, right? 1/6 times c to the 8 times d times 36 times c squared times d to the 4th. So I'm going to put the coefficient together. I'm going to put the c's together, and put the d's together. But you can go from here to the answer very easily, correct? So this is what you would see. You would see 1/6 times 36, and then times c to the 8th times c squared, just like this. And then the d's, the product of the d's, so you have d times d to the 4th. But we know that we can go from here to here very easily, because 1/6 times 36, which is what this is 6. C to the 8th times c to the 2nd, which is what this is, multiply like bases, you add exponents, is c to the 10th. And then d times d to the 4th, so d to the 1st times d to the 4th, d to the 1st times d to the 4th is d to the 5th. Okay? All right, let's look at number 10. So number 10, all right, number 10, let's suppose we had this. You want to simplify this expression. All right, so if you need to write it as separate expressions, then do that. In other words, you have negative 16 divided by, negative 16 divided by 4 times s to the 5th divided by s, right? Times, now be careful, you have 3 factors of t in the numerator but none in the denominator. So all you can do is say this, t to the 3rd, just like that, times, and then 4 factors of u, so u to the 4th, divided by 3 factors of u, so u to the 3rd. Now, to be on the safe side, what I would do here is I would write this as t cubed, t to the 3rd power, divided by 1. Okay? Now let's simplify each one. Negative 16 divided by 4 is a negative 4. S to the 5th divided by s. So I have 5 factors of s in the numerator, 1 in the denominator. But I know the quotient rule for exponents says that when I divide like bases, I subtract exponents. 5 minus 1 is 4, so that's s to the 4th. And then t to the 3rd divided by 1 is t to the 3rd. And then u to the 4th divided by u to the 3rd. When I divide like bases, I subtract exponents. 4 minus 3 is 1, so that's just u. And there's your answer. And you could have gone from here to here without having to write this down. Okay? Negative 16 divided by 4, negative 4. S to the 5th divided by s, s to the 4th. T cubed, there's no t factors of t in the denominator, so it stays t cubed. And then u to the 4th divided by u cubed, divide like bases, subtract exponents, 4 minus 3 is 1. Okay? It's a very simple process. It is not difficult at all. Okay, so I think that this should be enough for you. And so in this lesson, in this part of the lesson, we learned about the product rule for exponents, and we learned about the quotient rule for exponents. So when you multiply like bases, you add exponents. When you divide like bases, you subtract exponents. And that's it. It's a very simple concept.